Hello everyone, welcome back to a new video. In this video, we will be discussing the most important type of questions that might be asked in the further NLA Deloitte examination. So, NLA exam dates have been released, that is 3rd and 4th February. You will be having two shifts, that is 4:30 p.m. and 7:30 p.m. So book your slots now, and many people have registered to it, and the people who have not registered, click it as soon as possible, or else there might be some error from their side. So our responsibility is just booking the slot. So we will be solving five important type of questions based on the NLA pattern. So let's start with the first question. So first question is it is from lead code 167. To sum 2 input array is sorted. Given a one indexed array of integers numbers that is already sorted in non-descending order, find two numbers such that they add up to specific target number. Let these two numbers be numbers of index 1 and numbers of index 2, where the index lies between the length. So we need to search, or we need to just practically see that if in an array we have been given an array, so if we pick up any two numbers, the sum should be equal to the target. So the interesting thing over here is the search space is sorted. When the search space is sorted, we can use, it is very important to know that when the search space is sorted and we are making any operations on it, like addition, subtraction, multiplication, so we always need to see that two pointer approach comes into play. So we need to return the indices of the values where the sum of values is equal to the target. So it is a very straightforward question. So if we just take this test case, so if I just show you, if this is my test case, okay, what I would be doing, it is 2 7 11 15, right? I would be placing one pointer at 2 and one pointer at 15. So I will add them. So when 2 plus 15 is, I will compare, is 2 plus 15 which is equal to 17, and my target is 9 for here, right? Let's also take the target over here. So my target is 9. If 2 plus 15 gives us 17, is 17 equal to 9? No. So I need to do some adjustments. So if 2 plus 15 is greater than my target, then I will definitely do one j minus minus. Why j minus minus? If 2 plus 15 is only greater than my target, then the numbers ahead of 15 will always be greater than 15, the sorted thing, right? So you can know my j would be pointing at 11. So now I will do 2 plus 11. 2 plus 11 is 13. I will again compare. Is 13 equal to 9? No, 13 is not equal to 9. If 13 is not equal to 9, I will again see, is 13 greater than or less? It is definitely greater. So I will again do j minus minus. Now I am 2 plus 7. If 2 plus 7 is equal to 9, so I will return 2 and 7, their indices. What happens in the less than case? In the less than case, I will just do the I plus plus. I hope it is very clear. So now let's write the code for this. So we want two pointers, right? One, let's say one is I and one will be j. So I will do until I is less than j. First thing is I will calculate the sum. Let's say in sum is equal to numbers of I plus numbers of j. This is my sum. Now we will just compare. If sum is equal to target, if sum is equal to target, then I will return their indices. The indices is I and j. Else if my sum is greater than my target, if my sum is only greater than target, then I would be doing j minus minus. Or else the other case would be sum is less than target. Then here I would definitely do I plus plus. If anything is not there, then I will return an empty array. Let's run my code and check whether our logic is correct or not. There is a small mistake here. J is not 0. It would be numbers dot size minus 1. I would be pointing my index to the last size, right? So this would be numbers of 0. What is expected vector of integer, right? So we have not written right? Return statement is very important. We forgot to write the return. So this would be my code. So I am it is giving wrong answer. It was 0 1 but 1 2. Is the array one size one based indexing? Yeah, it is given a one index base. So I would be doing just I plus 1 and j plus 1. Now it would be running fine because it is a one based array. Generally it is always zero based, right? So you can clearly see one is at 0th location, one is at the last location. If my sum is equal to target, then I am returning the indices, or else if sum is greater than target, then I am just doing an decrement operation, or else I am doing an increment operation, return. This is one of the very favorite topics of these type of questions, like 2-pointer. It is the best approach. So let's move forward to the next question. Now moving forward to the next question, merge sorted arrays. Why always we are taking sorted? Because sorted things like binary search, sorting spaces, everything are very favorite to the service based of questions. So merge sorted array, what is the problem statement saying? You are given two integer array nums1 and nums2. So we have been given a two arrays nums1 and nums2 sorted in non-descending order. What is non-descending order? It is nothing but ascending order. And two integers m and m representing the number of elements, that is the sizes of both the arrays respectively. Merge nums1 and nums2 into single array in non-descending order. The final sorted okay. So it is a very easy question. So this is one of the array, this is other array. Here we need to merge these two arrays such that the whole array is sorted. Let me just say, let's consider let's leave the zeros for now. The zeros are not part of the array. We actually need to place these elements over here. So this is my array. So it is the first array and this is the second array. For now ignore the zeros. How we will handle the zeros is another thing. Now let's just understand 1 2 3 and 2 5 6. If these two are my arrays, then can I merge them? It is very easy, because see, the first array is sorted, the second array is also sorted. What I will do is I will create a new array of 6 size, that is size is 6. So it will be something 1 2 3 4 5 6. Why 6 size? See, the size of the first array is 3 and the second array is also 3. So the resultant array, when we combine both, the array size would be 6, right? So we would be writing 3 plus 3, that is 6. What I will be doing, I will be placing one pointer over here and one pointer over here. I will just compare which one is small. Definitely 1 is small, so I will write 1. Then I will increment 2 and 2, which is 1 no matter what, so I will write 2. Okay, not here but here, 2 comes. Then I moves here 3, right? 3 and 2 is really small, so 2 comes here. Then 3 and 5, which is small? 3 is small, so this array is completed. Now the only two elements are remaining, that is 5 and 6. You can just definitely write this is the sorted array, right? Now isn't it the sorted array? This is how we can simply do merging of two sorted arrays. This is how we do. It is also a 2-pointer approach, but the problem over here is there are extra zeros. For this we can definitely take one temporary array and do the same thing. Like we'll just consider up to here, we'll consider up to here, we'll make an array and we'll place that. You'll just understand, just wait and watch. So it would be like firstly we want one I pointer, right? I would be pointing at, let's say we will be starting from let's say from back, I minus 1, m minus 1 and j equal to n minus 1. So I am placed at I would be no okay we would be I here, n here, right? So we can definitely do something like we can not like this, but we can see nums1 is 1 2 3 000. This is 2 5 6, right? For this we definitely want one temporary array, as I said. So it would be of m plus n size, right? M plus n size. Now here we want int I equal to firstly before that return temp, I just want to see the size of m. Is it 3 or 6? See out m. This is for just for debugging thing. Okay, this is a void function, sorry. We need to place it in the same array. It is 3, right? That is what I was thinking. So the size of nums1 is 3 but not 6. Here as we see, we are seeing as 6 elements, but when I printed, okay, it was there already m, I did not see that. So m is 3, right? So we can do let's say int I equal to m minus 1, it would be pointing at second index, and j equal to n minus 1, and my k would be something like m plus n minus 1. This would be my location. Now see, temporary array is of size 6 because 3 plus 3 6, and k equal to m plus n. What is m plus n? M plus n is 3 plus 3 6, 6 minus 1 5. That is the last index at the temp, that is there is the total size of temp is 6. So but when the size is 6, the last index is 5, right? We are standing at k. So what we can do here is, it is very simple. I can do while I greater than or equal to 0 and then j greater than or equal to 0, because this is the boundary condition, we can't go beyond this. I'll just check if my nums1 of I is greater than or equal to nums2 of j, then what I can do? Then definitely I can do something like temp of k minus minus, I will store nums1 of I minus minus. I hope it is very clear, because when my first element is greater than the second element, then I will put it at the last, because we want in the descending order. Else what we can do, temp of k minus minus would be nums2 of j minus minus, right? But if we do, will it work? No, because when the size of m or n, here the sizes are same, so it would be working fine. But when the sizes are not equal, then for that we can definitely write another thing, right? When I exhausted or j exhausted, here we can write nums, for I it was nums1 of I, nums1 not, here we can write temp of k minus minus equal to nums1 of I minus minus. And similarly for j greater than or equal to 0, temp of k minus minus would be nums2 of j minus minus. This will fill my temporary array. For now, should I show you my temporary array? It would be something like this. I think we can't print like this the whole array. Yes, we can't print it. So for auto it in temp, cout it. For your understanding, I'm just printing it how my temporary would look now. Once temporary is figured out for you, the rest question is C. My input was 12300 MC. Not my temporary is sorted, right? 1 2 2 3 5 6. Did we achieve this? Did we achieve this? Right. So what is this output? We need to make changes in the nums1, right? So it is very easy now. See, we have made our temporary, which is in the sorted form. Now you can just iterate in your temporary. It would be temp dot size I plus plus. You can definitely do nums1 of I would be temp of I. This will rearrange our temporary, that is nums1. Now if I run, it would definitely pass. I hope it is very clear. I even logged our temporary arrays. See, even this is also with 100% efficiency. Now next question is very interesting. I chosen this question because this question was asked in the previous exam. So it is given as rotate array. What is rotate array? So let's take the example. So this is the example, right? So 1 2 3 4 5 6 7, this is my example, and k is equal to 3. So k equal to 3 and 1 2 3 4 5 6 7. So if you see here, what is this? Our output should be something like this, right? Let me even copy this. My output is something like this. How did we achieve for k equal to 3? So it is very simple. See, when 1 2 3 4 5 7, the array is rotated by 3 steps. What is this 3 steps is? See, 3 steps is ours was 1 2 3 4 5 6 7, right? For one step of rotation, for k equal to 1, let's take for k equal to 1, my thing would be something like the rightmost things would be in front. for k equal to 3, see the last three elements came front and the rest is same. For k equal to 1, what would be? It would be 7 1 2 3 4 5 7 1 4 1 2 3 4 5 6. For k equal to 1 this would be, and for k equal to 2 it would be something like, it would be first 6 then 7 then 1 2 3 4 5. Did you understand the pattern and logic? So how do we see? The approach is very simple. For this we will follow three steps. First, reverse the complete array. Do we know how to reverse the complete array? Yes, we know. There is an inbuilt function. We can do reverse nums dot begin comma nums dot end. In every programming language there is inbuilt reverse logic. You can definitely use that. So once we will reverse the thing, how our thing would be? It would be something like 7 6 5 4 3 2 1. Now we are at this stage. Now reverse the first k elements. First k elements would be something like reverse nums dot begin comma nums dot end. If we do, it would be something like nums dot begin is 7. Here nums dot begin is 7 and nums dot begin plus k, the k value is 3, right? 0 plus 3 is 3. We would be going up to this index. So it would be something like, now we are reversing 7 6 5. If we reverse 7 6 5, it would be 5 6 7 and 4 3 2 1. This is all. But we have achieved up to 5 6 7, but 1 2 3 4 is less. Now just reverse this. It would be nums dot begin plus k and nums dot end. It is nums not end. Here we will be writing nums dot begin plus k. Now here it would be reverse nums dot begin plus k to nums dot end. This, what this will do? We are reversing from 4 to the last. It would be now, it would be 5 6 7, and if 4 3 2 1 are reverse, it would be 1 2 3 4. This is the logic behind this question. I hope it is very clear. So things got accepted. Let's submit the code. There is a runtime error. Address and a heap buffer overflow. For one element we are getting this, right? Okay. Yeah, got it. For this you can see, this is one boundary condition. Here you can just do, if your nums dot size is only, if your nums dot size, okay, I think we should do the modulo operator, but I hope it is recovered from this one. If nums dot size is less than your k, then I don't think we will do anything. We'll just return over here. Let's see, or else we'll come up with another approach. Okay, something is okay. My nums is 1 2 and k is 7. For this, let me think. For k equal to 1, it would be 2 1, again 1 2. Okay, for n equal to 6, it would be 1 2. Okay. I think we need to do int n equal to nums dot size. Let me think over this. Int n equal to nums dot size and k equal to k mod n. I hope this will fix that. Let me see. Let us try. We should not panic. Yep. Let me explain what has happened here. So what was happening over here is, see, why did I do this k equal to k mod n? Let me explain. Here in the previous code, when we were this was runtime error. Why we were getting is, when your size is only -1, but this if the size is only less than the k, but we are not more I mean the k value is more and we are doing it is one same repetitive process, so we are getting a runtime error. But wrong answer why did we encounter over here is, see, why did I do n equal to n, k equal to n, k mod n is, see, 1 2 and 7. For k equal to 1, 1 2 would be 2 1. For k equal to 2, 1 2 would be 1 2 only. It will not change. For k equal to, it is the same repetitive process, isn't it? For k equal to 3, it is 1 2. It is 2 1. And k equal to 1 is also 2 1. K equal to 5 would be 2 1 again. Again 7 would be 2 1 again. So it is not, don't you think it is a repetitive process? See, the answer for k equal to 7 is the answer for k equal to 1, right? The answer for, see, the k, if my k would be 1, the answer would be 2 1, right? And k equal to 7 is also 2 1. Why it is happening? Because when your size of the nums is only less than the k, the process becomes repetitive. That's why for the time limit exceeded or other errors, I have just done the k equal to k mod n. This is preventing the most of the errors and thing. I hope it is very clear why did we do k equal to k mod n. By this we see, the first question we solved in 100% efficiency, the second question we solved in 100% efficiency, the third question also we solved in 100% efficiency. I too did not solve this question anywhere. I came up with the process now. Like I had the logic like we need to reverse and, but even I was stuck over here. These are the things that we come over when we write code and debug our things and everything. So don't panic in your exam. You just debug things, log things, you will come up definitely with some of the answers. So let's move forward to the next question. Now the next question is, don't get I mean what we say, frightened or something, afraid from seeing like, does Deloitte ask 3 questions? No, it won't, but it is one good type of question that majorly everyone asks. It is not basically on what we say, trees and all. It is a tree question, but we will be not solving it in a tree manner. We will be solving it in a array manner. So, okay. So we need to validate binary search tree. So we will be given a tree, and our aim is to check that if the given tree is a binary search tree or not. First, let me explain what is a binary search tree. So first let me explain with tree. Tree is a non-linear data structure. Okay. So array is a linear data structure. What is the difference between linear and non-linear? Linear data structure is a data structure which stores data in a structured format, that is sequential or something contiguous manner. But non-linear data structure is a data structure where the elements are non-structural, non-contiguous. So tree is one of them. So in this tree, the first thing is called the root element, and this is the left, this is the right, this is okay. For the people who know trees and can understand, listen well further. No problem if you don't understand. So the process which I say here, the type of function we do here with recursion, that is very important. Let's just understand. So we need to check whether the tree is binary search tree or not. One important property of binary search tree is, when you do the in order traversal of a binary search tree, the traversal output is in a sorted format. It is a property of binary search tree. So let me come again. If you do a in order traversal, what is in order traversal? In order traversal is, first it will traverse the left, then the root element, then the right element. The in order traversal for this would be, I said left, root, right. So it would be 1, 2, 3. Okay, here the tree is very small, so we are easily seeing. What about a bigger tree? So here the in order traversal would be left, root, right. I said right, left, root, right is the in order traversal for this. If you do an in order traversal for this, the in order would be 1 5 3 4 6. Is the 1 5 3 4 6 in a sorted order? No, right? So here we are returning a false. Here the order is 1 2 3, so we will be returning a true. Before that, we have understood what is in order traversal, but what is a binary search tree? Binary search tree is, there would be a root, the elements to the left of root will always be smaller than the root element, and the elements to the right of root will always be greater than the root element. This is about the property of binary search tree. Okay, this is a property of binary search tree. And the important property is, when you do a in order traversal of a binary search tree, the output is sorted. Now let's understand. Here we'll use a helper function, helper. Okay, this will give our answer, and we'll pass our root. For now, let's declare one in order. Okay, let's not name this as helper. Let's write get in order of bst. Okay, get in this function will give me the in order traversal of bst, not return bro, will get. Okay, will get in order bst, in order of bst. Let's write the void function, void get get in order, get in order of bst of tree node star root. If my root is equal to null, then I will return, right? And now it was left root right, so I will go left get, I will call the same function. Left is nothing but in order of, get in order of bst. And here how do we go left? It would be root arrow left. This will call my left function. Here we need to append our things. It would be something like in order dot pushback, that is appending your answer, root ka value, value, that is value is data, right? Now we will call the same function, get in order, get in order of bst, get in order of bst, and here we'll call our right, that is left root right. This will fill my in order. Now we have the in order. Now if I just print see, for auto it in my in order array, and if I print my it, you can see for the test case number 1, we need to return, right? Let's return false for now. Let's return false. Okay, so our output for this 213, it was returning 123. We are returning false, but expected is true, right? Okay, for the second thing, the in order for this is 15346. Is this sorted? No. So if it is not sorted, we will be returning a false. Now here we can definitely easily verify if the thing is sorted or not. Let's traverse. For int I equal to 1, I less than in order dot size, in order dot size I plus plus. If my in order of I, if my second element is less than the first element, I minus 1, then it is not sorted, right? Return false. Over this we will return true. I hope it is very clear. This is the logic. Okay, now let's run and submit our code. We are getting a wrong answer. Let's see, std out 222. Are we printing something? Okay, we are just printing, right? Let's submit now. Okay, so there is also duplicate elements. How to solve for duplicates element is, so if it is also equal, then also we will be returning false. I thought there are no duplicates in this. A binary search tree typically don't have duplicates, so I just assume that there are no duplicates. Once we do an equals case also, we will be sorted. Even this question got solved in 100 meters per second efficiency, which is the best efficiency. So now moving forward to the last question, and very important and very interesting question. This question is pure logical, and this is a dynamic programming question and very important for product companies. Okay, so we'll be solving this, and TCS and all are also in a race of asking these types of questions. And let's rename this SNT. Who will write text 1, text 2? Don't do this in exam. Follow the convention. Here I am doing. So the question is longest common subsequence. So we need to find and return one integer which represents the longest common subsequence of these two strings. It is very famous question. Let's understand what is the question stating. See, here if you see, what is a subsequence? Subsequence in the same order but not contiguous. Substring is same order and contiguous. Subsequence, the contiguity doesn't matter until it's in the same order. So the text one is A B C D E and text 2 is ACE. The common subsequence is ACE. Here also ACE. ACE are in the same order. So ACE are subsequence in the both. Here CE is also a subsequence. CE is also a subsequence. Only E is also a subsequence, but we want the maximum, right? The maximum is ACE. Here also ACE. So we need to return that. In the second one, ABC both match. So this is the longest subsequence, returning 3. Here ABC DEF. There is no subsequence. Here we are returning 0. So this is the question that we have been stated. So we need to solve this question. Okay. How do we solve? How do we solve is a big challenge for this question. So let's understand very clearly. If you can see, 15,000 people have voted this solution. That is voted this like this question. So it is very important and very famous question. So it is a pure recursive approach that we would be following. We would be starting from the last thing. Okay, we would be comparing the both text. That is, let's suppose my pointer one is at E and here it is E. So if both got matched, then one part of my sequence got matched. So I will add 1. If both doesn't got matched, I will search from here and here. This would be my approach. Let's try to understand what we are doing. Okay. First, we would be requiring the length. So the length would be s dot length. It would be s dot length and let's say m as t dot length. Okay, we got the length, and here we would be returning an helper function, or let's write get LCS of strings. Let's write meaningful convention. Here this you will be writing in interviews but not here. Okay, we will be starting with the last indices. Okay, we are sending the last indices. So let's also receive. Here we will be writing get LCS of strings. It was strings, right? First one would be string ampersand s comma string ampersand a passing by reference int i comma int j. Okay, now the first boundary condition would be if my I got exhausted or my j got exhausted, then we would definitely return as 0 because we can't go beyond that. Now first case was if characters got match. If both got matched, then we will add 1 because it is part of our answer. When characters got matched, we can definitely do something like return 1 plus same function. Let's copy this. How many times would be writing this? Copy, and would pass s comma t. See, now E and E got matched, so I would be searching CA and DCBA. So it would be ST comma I minus 1 comma J minus 1. This would be it. Now if both did not get matched, I would return maximum of if, let's say, for now ABC and DEF, F and C did not match. Now I would do FED and BC ka LCS and ED and CBA ka LCS. इन दोनों में से the whatever gets the maximum LCS, I will return that. So it would be simply get LCS of s comma t comma I minus 1 comma j comma get LCS of strings of s comma t comma I comma j minus 1. This would be my code. If I run this, we would definitely get my answer. We are getting a wrong answer. Why are we getting a wrong answer? Let's analyze. We are getting 3 but expected is 0. Let's see. Let's see. Get, oh, we are not comparing and returning here. Let's that's very strange. If when character check, where is the character check? If s of I is equal to t of j, then only we will return this, right? Let's keep some indentation. So now we will be getting definitely a correct answer, because we are always doing return 1 plus so when the characters get matched, only then we will do this. So if I submit this code, we'll definitely get a time limit exceeded. I'm pretty sure. Did it get okay? Time limit. I thought we got accepted. Time limit for Deloitte NLA exam. Until here, the code is very much clean. We can definitely do this. Our NLA exam questions would not expect the candidates to solve more than this. Writing this recursive piece of code is only very much greater. People generally don't understand these things, and if you are able to pull off this solution, then there is something about you. Because writing DP is, once you write the memoized solution, writing DP is piece of cake. Now let's see. There are two things that are changing, right? It's state. So we will require a 2D DP. The people who are not interested can skip over here, but two things are getting changed, right? That is I and j. So we will be requiring a 2D state. The thing only required in DP is the memoized code is done. So we can definitely do dp.resize of n plus 1 comma vector of int m plus 1 comma minus 1. Now I will do just the two things. If my thing is already calculated, I will not make any further calls. I will return that. Return dp of ij. This we will do. And before returning everywhere, we'll just store our result. What we'll do? Just store our result. dp of ij is equal to this. And here also we'll store our result. By doing these minimal changes, our thing gets accepted. This is about DP. People think DP is very large, huge, very difficult. This is very easy. DP is very easy. Until when we are able to write the memoized code. DP is not tough. Recursion is tough. Okay, things got accepted. So this was about our video. We have understood the different types of questions, patterns, everything. So I hope you the very best, and I think I was able to discuss few of the questions that are important, and this session was helpful. And if you want more type of questions, you can definitely make a comment or leave a like, which makes him motivated. It's around 12:17 at the am, that is 12:17. Still working. I would be editing this video, I would be sending. There is definitely so much of hard work. If you like this, you know the drill. You can just like or comment or do anything. You can definitely give a feedback. It would be constructive, or it would be taking. You think you can say you would be very fast, things did not understand. You can definitely comment what you feel. I hope I was able to make you understand how things like how to tackle question. When I was also stuck at one question, I came up with some solution. You can also get. So I hope you the best, and I hope you get selected in NLA, get your first placement or something. I hope you the very best, and thank you. We will be meeting in some other question. Until then, bye bye. Take care.